Assalamualaikum warahmatullahi wabarakatuh. My name is Aiman Syauqie Razali, and now I am going to explain about the introduction of our group project. The Arduino Mega, with its powerful processing capabilities and numerous I/O pins, is ideal for integrating sensors like the KY026 flame sensor. The KY026 detects flames by sensing infrared radiation and offers both digital and analog outputs, enabling precise signal analysis and customizable threshold settings. When paired with the Arduino Mega, it becomes a reliable tool for applications such as fire detection, safety monitoring, and automation, allowing for advanced features like alarms and automated responses. In our instrumentation project, we tested the KY026 flame sensor using the Arduino Mega and custom code to evaluate its functionality. The experiment focused on three objectives: analyzing the sensor's performance in detecting various flame sources, assessing its sensitivity and detection range in different scenarios, and calibrating it for optimal results. These tests provided valuable insights into the KY026 efficiency and potential uses in diverse environments. The three objectives are: first, evaluate the performance of the KY026 flame sensor in detecting various types of flames and sources, such as smoke, heat, and infrared radiation, and analyze how these factors affect its detection capabilities. Second, investigate the sensor's sensitivity and detection range by testing its performance at different distances in diverse scenarios. Number 3, calibrate the infrared sensor to optimize its detection range and sensitivity, ensuring reliable and consistent results under a variety of environmental conditions. As for the scope for our project, first, evaluate the KY026 flame sensor's ability to detect various flame types. Number 2, conduct control experiment with varied setups to measure the sensor's sensitivity and detection range. Number 3, the KY026 reliably detects infrared light from sources like a torchlight but fails to detect heat from sources like a hairdryer, highlighting its limitations and dependency on proper calibration. And number 4, address challenges identified during testing and suggest improvements to enhance the sensor's performance for broader applications.
Assalamualaikum warahmatullahi wabarakatuh. My name is Afiq Alhadi, and now I will explain about the main element in measurement system. So for the main element, it has 5 elements, which is sensing element, signal conditioning, data transmission, data processing, and data output. So for the firstly, for the sensing element, the main component that communicates with the physical process or environment, which is it convert the physical parameters such as temperature, pressure, and light to the electrical signal. Next, for the signal conditioning, it is enhanced raw signal from sensing element for further processing. Then for the data transmission, it sends the process signals to the monitoring or control system. It also depends on the application, communication method, and that may be either wired or wireless. For the 4 element is the data processing. It is analyze the received signals to determine the necessary control action or produce alarm. And lastly, for the data output, the actionable feedback is sent to the control system, and it is including the activating fire suppression system and shutting down the equipment. That's all from me. I will pass to the next presenter.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Maulana, and I will continue our presentation with the explanation about our flame sensor lah. So the module that we use is KY026 flame sensor. The KY026 flame sensor is also known as infrared IR fire sensor detector lah. So it special kind of module that construct for flame or light source. It detect light, specifically for infrared radiation that emitted by the flames or source, similar source lah, like torchlight that have tungsten that produce infrared radiation. So the specification for this KY026 flame sensor is the light source of wavelength in range 760 nanometer to 1106 nanometer. The detection range is up to 100 centimeters. The detection angle is 60 degree, and the dimension for this flame sensor is 1.5 centimeter multiplied with 3.6 centimeter.
Alright, so I want to present about the main component of KY026 flame sensor. For the first component is infrared receiver, IR photodiode. The description for this component is detect light infrared radiation emitted by flames or similar sources. Next, LM393 comparator IC. The description for this component is process the analog signal from IR sensor, convert the analog input into output based on threshold. Next, adjustable potentiometer. This function of the component is allow sensitivity adjustment. Last, the light emitting diode LED. There's two LED in this component. First LED shows the voltage has been supplied to the sensor, and the second LED shows that the sensor detect a flame. Right now, about the working principle of the flame sensor that has been used. First, flame detection. The KY026 infrared flame sensor detects infrared radiations emitted by flames. Flames produce a specific wavelength of infrared light, which the sensor's IR receiver captures. This receiver, typically a photodiode or light-sensitive component, convert the incoming infrared light into an electrical current or voltage. A larger flame emits more infrared radiation, generating a stronger electrical signal. Next, signal processing. The IR receiver signal goes to the LM393 comparator, which compares it to a user set threshold. This threshold is adjustable using a potentiometer on the sensor module. By turning the potentiometer, you can set the sensor's sensitivity to detect small or large flames as needed. Last but not least, the third working principle for this sensor is the generation of output. The comparator checks if the IR signal exceeds the set threshold. If it does, the DO digital output goes high, triggering an LED to indicate the flame detection. The A0 analog output provides a voltage proportional to the infrared signal strength, allowing precise measurement of flame intensity. These outputs can trigger alarms, control systems, or monitor flame strength. Alright, for this part about the alternative sensor, we choose Hamamatsu R2868. This sensor is a photomultiplier tube. It's quite sensitive for enabling the detection of lights, even of low levels. This is a very special kind of sensor used for applications which really need extreme sensitivity, such as scientific research. The detection of radiation and spectroscopy. So here about the comparison of working principle of KY026 sensor and R2868 sensor. For the first aspect is the detection mechanism. For the IR film sensor, works based on a light-dependent resistor, LDR, where the resistance of LDR decreases as light intensity increase. The sensor detects the change in resistance to estimate the light intensity. Meanwhile, for the PMT, which detects light through the photoelectric effect, when light photons hit the photocathode, they release electrons, which are then multiplied through diodes to produce an amplified signal. Next, the second aspect is sensitivity. For the IR film sensor, it has low sensitivity suitable for general light detection. It is ideal for applications that do not require detection of very weak light source. Meanwhile, for the PMT, it offers high sensitivity capable of detecting low level of light. It is perfect for precise, low light environment like scientific research. Last but not least, the last aspect is output. For the IR film sensor, output a digital signal or an analog signal depending on the configuration, typically with a simple comparator circuit that triggers at the certain light threshold. Meanwhile, for the PMT, outputs an amplified current signal proportional to the light intensity detected, providing more detailed and continuous data about the light level.
I will continue our presentation with the chapter 3, the develop, process and description of system. So before we do the hardware experiment, we do the design in the Tinkercad to see either our design and our coding is working or not. So the step, we have 3 steps in using the Tinkercad. The first one is we select the hardware that available at the Tinkercad. The first one is Arduino Uno. The second one is IR sensor. The third one is buzzer. The fourth one is breadboard, and the last one is jumper cable lah. So next is we connect all the component to the Arduino Uno, whereas the IR and buzzer, ground pin and negative pin connect to ground pin at our Arduino. The digital output pin at IR, we connect with the PWM pin number 3. The VCC of IR, we connect to the 5V pins at the Arduino. And the last one is positive pin, we connect of buzzer, we connect to PWM pin number 4. And the last step is we insert the coding, then we can start the simulation. Then if you see at the serial monitor, if there have an input, so the coding and our connection of wire is correct lah.
Assalamualaikum warahmatullahi wabarakatuh. My name is Afiq Alhadi, and now I will explain about the hardware setup. So for the hardware setup, the components that include are KY026 flame sensor, Arduino Mega 2560, buzzer, jumper cables and USB cable. So for the KY026 flame sensor, it has 3 pin, which is the ground pin, the DO pin and the VCC pin. For the ground pin, it is connected with the ground at the Arduino Mega. For the DO pin, it is connected with the PWN at pin number 3, and for the VCC pin is connected to the 5V pin in PWM. Then next for the buzzer, it has two pins, which is the positive pin and the negative pin. So for the negative pin, it is connected to the ground, to the another ground at the Arduino Mega, and for the positive pin, it is connected to the PWM at the pin number 4. For the calibration parts, at the calibration part, we adjust the potentiometer to make a sensor detect the infrared within a range of 100 cm. For the apparatus, we use KY026 flame sensor, Arduino Mega 2560, jumper cable, testpan, lighter, and the buzzer. So for the procedure to calibrate this sensor is, firstly we set up the flame sensor, which is we connect all the pin that have at the flame sensor and add the flame sensor to the Arduino Mega, and then after we finish set up the flame sensor, we upload the code using the Arduino IDE, and then we set up the power, which is we connect the Arduino to the computer using the USB cable, and then after we done all the step, we adjust the potentiometer, which is use the testpan to adjust it, and we rotate clockwise to increase the sensitivity if the flame is not detected, and we rotate counterclockwise to decrease the sensitivity if the sensor detect the flame at the excessive range. And then we test the calibration, we observe the sensor output on the serial monitor, and lastly we repeat the test to know the result with approximately.
So in this project, we do different experiment that have different objective. The first experiment is we need to determine the flame detection capability, whereas our sensor is detect a flame or not. We need to see if our sensor is function or not lah. The second experiment is we do the differentiation, different thing between infrared radiation and heat. As we know that flame produce two type of source lah. The first one is heat, the second one is infrared radiation. So we, in the second experiment, we want to see either the flame sensor is detect heat or infrared radiation or both. So the last experiment is we need to see the assessing sensitivity consistency across the detection range. So in the third experiment, we want to see that our sensor have detect the range in constant or not. For example, if we set randomly the range of the sensor like 20 centimeters, does our sensor have constant detect the flame at 20 centimeters or not? So if not, then the sensor is malfunction lah. So that's all from me. I will pass to the next presenter. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. So now I will present about the result and discussion part. So for the first experiment, the sensor got an actual flame detection during all three trials, thus asserting the sensor capability to identify the flame railway. So this result proved that the sensor achieved its main objective and thus can be used for the fire safety system, where the reliable flame detection is of utmost importance. So as you can see, for the first attempt, the sensor will detect, and the second attempt also the sensor will be detect, and the third attempt sensor will be detect. So for the second experiment, infrared radiation was generated by a torchlight, while a hairdryer generates heat. It was found that the sensor detect infrared radiation coming from torchlight on our tree concession. Why I did not react to heat from the hairdryer. So the table show the KY026 flame sensor operate on detecting infrared radiation but not to heat. These characteristics make the sensor particularly effective in environment where heat might be present but does not necessarily indicate a flame. For the last experiment, the sensor was tested at several great distance which revealed minor variation in detection, given as 90.1 cm, 19.6 cm and 19.8 cm in 3 instances. So this came and the average distance we can get approximate at 19.5 cm. So this can be said to denote that the sensitivity of the sensor remain fairly consistent over its range of detection, a property necessary to application that need reliable flame detection and varying distance. So that's all for me. Thank you.
In summary, the experiment successfully achieved the project's objectives. However, using the KY026 flame sensor and Arduino Mega presented several challenges that required further optimization. Environmental noise, such as bright light or reflective surfaces, caused false flame signals, while smoke or dust blocked the infrared signal, reducing detection accuracy. Another issue was adjusting the sensor's sensitivity. Calibrating the potentiometer was difficult, often resulting in missed detections or false alarms. The lack of real-time feedback made this process time-consuming. Additionally, the sensor's limited detection range required precise positioning, with misalignment or distance leading to unreliable readings, making it less suitable for larger or dynamic setups. This project also emphasized the importance of proper calibration to ensure accurate and precise measurements, highlighting its role in achieving optimal results. So for the recommendations, there are 3. The first one is to calibrate for accuracy. Adjusting the sensor's sensitivity threshold using its onboard potentiometer is essential to ensure accurate performance. Calibrate the sensor for the specific environment where it will be used by testing it under realistic conditions to find the most reliable settings. Number 2, minimize environmental noise. Reduce false readings caused by bright lights, reflective surfaces, smoke or dust by implementing noise reduction strategies. Use physical shields to block unwanted light and software filters to process noisy signals, ensuring the sensor responds accurately to flames. And number 3, extend detection range. Improve the sensor's limited range by adding additional sensors to cover larger areas or incorporating tools like small fans to clear dust and smoke. Alternatively, consider upgrading to a higher quality sensor capable of detecting flames at greater distances for better performances. That's all for me. Thank you.